A wave is a disturbance that travels through a medium from one specific location to another. The main characteristics of a wave are frequency, wavelength, crest, throw, periodic wave, and velocity. The different ways in which you can consider sound can be transmitted are in air, on a fluid, for example in water, on gas, for example air, and on a rod that are, for example, a metal bar. The properties of a wave are frequency, wavelength, speed, periodic wave, and amplitude. A mechanical wave can transport energy through a vacuum. It needs a medium in order to transport their energy from one location to another. Some examples are sound waves and water waves. And the longitudinal wave. The transverse waves are when the particles in a medium vibrate perpendicular to the direction of the wave's motion, and they only transfer mass. And the longitudinal waves when the particles in a medium vibrate back and forth in the same direction of the traveling wave, and they only transfer energy. To get the velocity, you use this formula that it multiplies the wavelength times the frequency, and the frequency is 1 over the period, or velocity over wavelength. The wave's characteristics are wavelength, which is the distance between adjacent maxima or minima of a wave, the periodic wave, which is a wave that repeats every time in space, also called continuous wave, the crest, which is the highest point on a transverse wave, also called the peak, the throat, which is the lowest point on a transverse wave, expansion, which is a point of maximum spacing between particles of a medium for longitudinal waves, and compression, which is a point of minimum spacing between particles of a medium for longitudinal waves. A mechanical wave is the one that needs a medium to travel. For instance, sound needs a medium like air to travel, and also sea waves need water to displace. There are two types of mechanical waves, which are the transverse waves and the longitudinal waves. Then the results that we got is for 1.5 hertz of frequency, we got a 0.005 meters of amplitude, for n, a velocity of 0.047 meters over seconds, and a wavelength of 0.073 meters. For an amplitude of 0.008 meters, we got an n of 4, a velocity of 0.075 meters over seconds, and a wavelength of 0.073 meters. And for a frequency of 1.8 hertz, we got an amplitude of 0.005 meters, an n of 4, a velocity of 0.056 meters over second, and a wavelength of 0.073 meters. And for the conclusion, we have we know that all have the same lambda, and two of them have the same frequency, although that the velocity changes, the amplitude, and all of them have the same number of nodes. Thank you, teacher. Bye.